This video is on function notation. Those of you in my class have some slotted notes that you should fill in. A function is a relation where for every possible value of x, there exists one and only one corresponding value of y. F of x is read f of x, and it tells us that an equation is a function. So if we use this notation, we are saying that this is a function. Being a function of x means that the value of f of x, which is like the y, depends on the value of x. X is called the independent variable, and f of x, or y, is called the dependent variable. So there's a lot of new terminology here to work with, but the main thing is the fact that we use f of x in place of y in the equation of a function. So f of x doesn't mean f times x or anything like that, which I know you're used to seeing parentheses and you think you have to multiply it. F of x is a function called f, and it's being defined in terms of x. It sounds more complicated than it is. Let's look at an example. Instead of y equals 2x plus 1, using function notation, we write f of x equals 2x plus 1. That's it. The equation itself doesn't change. If we were graphing it, the slope and the y-intercept is still in the same place. We do it the same way, but instead of y, we write f of x. That's it. Using function notation, we don't use y. We use f of x instead. You should know that they could use any letter. The most common one is f, but it's often g of x. It could be m of x. Any letter could name the function, but it is generally in terms of x. And so that's the next part of this. Different letters can be used to name functions. Here's a couple of examples. It still works the same way. G of x equals x minus 3 means y equals x minus 3. Those still are there in place of the y. Using this notation, we can evaluate a function for a certain value of x. It's important that you know this word, evaluate a function, because what it's telling you to do is plug something in for x. And so in this example, we're given f of x equals 2x plus 1 and asked to find f of 5. I want you to look at that. What's in place of the x? Instead of f of x, I just wrote f of 5. Instead of the x, there's a 5. And that is exactly what you're going to do to the equation. Instead of x, you're going to put a 5. And so we'll take it, and instead of 2x plus 1, we'll say 2 times 5 plus 1. And that's 10 plus 1, which is 11. And so evaluating a function for a certain value of x, we found f of 5 by taking x and making it 5. You try this one below, pause the video, and when you come back, you'll see if you got it right. How'd you do? I suspect some of you didn't put parentheses around your -3. And if you didn't, your calculator, if you used it, actually gave you a different answer. It's very important when you plug anything in for x that you always use parentheses. And those parentheses happen before you square the -3. Because -3 in parentheses squared means -3 times -3, which is positive 9 minus 1 equals 8. If you didn't use the parentheses, especially if you're using your calculator, it's going to square the plain 3, the positive 3, and then make the answer negative, which would give you negative 9 minus 1, which is negative 10, a very different number than 8. The bottom line is that if you got negative 10 for your answer, you didn't put parentheses around that number you plugged in, and that is vitally important. If we needed to plot the result on a graph, we need to know what that will look like. And so when you do that, you can plot f of x and g of x. And you'll notice let's just try f of x. If my y-intercept is 1, my slope is 2, and so this is my line, not a very good one, but this is my line. F of 5 was equal to 11. What that means is that when x is 5, y is 11. This is a very important concept because this point is on the graph of this line. And of course, mine isn't quite big enough, but 1, 2, 3, 4, 5, this goes up to 10, so 11 would be about here. And if I drawn this straight, it certainly looks like my line would extend through that point. The idea here is understanding what function notation is telling you. This says when x is 5, y is 11. And that's very important to understand what it is you're looking at so that you can work backwards if you need to. The next part of this is vocabulary, and really what I want you to do at home is to get all of this down in your notes. During class, I'll go over each of these words and we'll talk about what they mean and how to use them. Some of it we've talked about, but most of it needs a little more clarification. Make sure that you stop the video and write all of this in your notes. Leave enough space to draw an example if you need it when we get to class so that you can add to it and make your notes more understandable for you. That's it. We'll do the rest in class. Make sure you get this written down.